All right, so like I said, we're going to start out with 9.2 support. And like I said, it's just to get us ready for the actual college algebra problems, okay? So the first one is going to be solving equations. Where we have a fraction equal to a fraction. So I'm going to have something like A over B equals C over D. All right, y'all. So when we got a fraction equal to a fraction like this, the way we solve this, our first step is to do what we call cross multiply. So that means I'll take the top of one side times the bottom of the fraction on the other side. So I'll get A times D. That'll equal the bottom of this fraction times the top of the second fraction, which will give me B times C. So I cross multiply to get rid of the fractions, and then I will solve for the variable. So two of the problems that we start with are going to deal with this principle right here, okay? So the first one in support says solve 6 over x plus 1 equals 5 over x minus 3. All right, so we're going to solve this for the x, but our first step is to get rid of the fractions by doing our cross multiplying. Now, what you got to remember, when we cross multiply, this 6 has to multiply by both of those. So I would have 6 times x minus 3. So that gives me my left side. That's going to equal this x plus 1 times that 5. So both of these will get multiplied by the 5. So that'll give us 5 times x plus 1. All right, y'all, at that point, get rid of your parentheses by distributing. So over here, I get 6x minus 6 times 3 is 18. That'll equal the right side. 5 times x is 5x plus 5 times 1, which is 5. All right, so now we got an equation, variables and numbers on both sides. So I'm going to move all the variables to the left side and all the numbers to the right side. So first I'll subtract my 5x. So y'all, that'll give me 6 minus 5 leaves me 1x minus this 18 equals this positive 5. And y'all, at that point, add 18 to both sides. And we get our x equals 23. Okay. So now if you wanted to check this, you could put the 23 in for the two x's and then check that and see if they are equivalent, okay? All righty, let's see. Next one like that has x plus 5 over x is going to equal a 4/3. All righty, y'all. So cross multiply again. Remember this top, both the x plus 5, got to multiply by the 3. So that'll give me 3 times the x plus 5. And then this x times the 4 will basically give us a 4x. All right, distribute, get rid of your parentheses. You get a 3x plus 3 times 5 is 15. That's going to equal 4x. So y'all check this out. I got variables on both sides, but just a number on the left side. So I'm going to put all the x's on the right side, and then that'll leave the number on the left side and the x's on the right side. So we would subtract 3x. So you just look at these equations and see what's, easier for you to move, okay? So this is only a 15 on this side. And then 4 minus 3 leaves us 1x on the right side. All right, so that's the way you solve it when you got a fraction equal to a fraction. So now we're going to look at another property. And this will be solving equations with radicals. And your radicals are like your square roots, your cube roots, and all that fun stuff. So if I got two sides that are equal, so if A equals B, so if I got two sides that are equal, then I can raise both sides to the same exponent and they'll still be equal. So what that means is if I square one side, I square the other side. If I cube one side, I cube the other side. Because when you solve equations with radicals, the first step you want to do is get the radical term by itself. Get the radical term by itself. Whoops. On one side or the other. Now, after I've got this square root or this cube root on one side by itself, then I raise both sides to the exponent that matches the radical. So y'all, what that means, if I got a square root, then I'm going to square both sides. If I got a cube root, then I'm going to cube both sides, okay? That's how we get rid of radicals. If you got something like a number under a radical and you raise it to the exponent that matches this radical, the exponent cancels the radical, just leaving what was under that radical, okay? Now, y'all, once we raise both sides, the radicals will be gone. So then solve for the variable. Okay? So remember, now check this out. If you got a radical like that, that does not have a number in the little notch, then this means that that is a square root. Okay? They don't have to put the 2 in the notch if it's a square root. But if it's a cube root, they got to put a 3. A fourth root, they got to put a 4, and so on, okay? So just remember, if we don't have a number in that radical like this, then we're going to square both sides because it's understood to be a 2. All right, y'all. So these equations are going to say solve. So we're going to solve a square root 8x minus 9 equals 1. So remember, my instructions said get the radical term by itself. Well, y'all, this radical is by itself over here because this 8x minus 9 are under the radical. So there's nothing you can do. You can't add 9 to both sides because that 9 is under that radical. Before you can move these numbers, we got to get rid of the radical. So what we're going to do here, remember, that's a 2 in that notch. So what we're going to do is come down here and square both sides. That means raise both sides to the second power. So I'm going to square the left side, and I got to square that 1 also. Because remember, what I do to this side, I got to do to this side. Well, y'all, what happens now, this radical cancels with the exponent, leaving the 8x minus 9. And then on this side, 1 times 1 is 1. So look, by squaring both sides, we got rid of the radical. Now we're going to solve that for that x. So y'all, add 9 to both sides. I get my 8x equals 10. And then divide both sides by the 8. So that cancels, giving me my x. Now, we can't divide the 8 by 10, or 10 by 8, but we can reduce that. So you got 2 even numbers there. So that means both of these numbers will divide by 2. So if I divide the top and bottom by 2, I get a 5 over 4. Okay, so the whole trick, get this radical by itself and get rid of it, okay? So y'all watch this one. We're going to solve square root of 5x plus 2 is going to equal 15. Now, y'all, if you notice, this radical is not by itself. So we need to do something to get this square root of 5x on this left side all by itself. Now notice, up here I couldn't move the number because it was under the radical. But y'all, this 2 is not under that radical. It's out here by itself. So if I want to get this radical by itself, we're going to come in and subtract 2 from both sides. That's going to give me my square root of 5x. And then 15 minus 2 gives us 13. All right, this radical is now by itself. So y'all, we're going to square both sides. So we'll take our square root of 5x and square that. That's going to equal 13 squared. All right, y'all, so we know what's happening here. This radical is canceling with that exponent, leaving that 5x. All right, y'all, let's see. We got 13 times 13. Let's see, 13 times 13. Well, if y'all went to school in Arkansas, we quit at 12 times 12, pretty much. I think that's what, 169. All right, last step. Make that 5x a 1x by dividing both sides by 5. Well, that cancels my 1x. And y'all, that does not reduce. So that's going to give me a 169 over 5 as my final answer. So y'all getting the idea on these radicals? Because I got a couple more of these. I just want to make sure y'all are getting the idea.
Yes, I am.
Okay. And y'all, all that y'all lead me on this one, what y'all would do. This one has a solve a cube root of x equals -3. So y'all, my first move, really my only move to do on this, is to get rid of this cube root radical, right? So since this has a 3 in the notch on this cube root, we're going to cube both sides. So we'll bring down our cube root of x and cube it. That'll equal my -3 cubed. Now remember, always put negative numbers in parentheses when you're messing with exponents, okay? Now over here, this cube root cancels with that exponent, leaving your x. Now we got a -3 times a -3 times a -3. So that's a negative, what's that? 9 times 3 makes that a -27. Okay, y'all? Now, if you put that -27 in here, cube root of -27, well, that is a -3. Okay, so these will check out if you plug them back in. All right, y'all. So the last one for support. Solve the cube root x plus 5 equals 6. All right, y'all. First move. Got to get rid of that radical. So we're going to come in and cube both sides. Woo, so this radical cancels with the exponent, leaving what was under it, which was the x plus 5. Well, all right, y'all. 6 times 6 times 6. That's 200 and something. Let me check that out. $216. Now, since this 5 is now outside of this radical and the radical is gone, now I can actually subtract it from both sides. That's going to give me my x. And let's see, 216 minus 5 leaves us 211. So if you put 211 in there, you get 216. Cube root of 216 equals 6. So y'all, they check out when you plug them in, okay? So that is the support. And I wanted to do it first so that when we get to the part where we start solving equations, y'all would sort of know what was going on, okay? All right, let me put that calculator over there. So y'all, now we're going to get into our 9.2 for college algebra. And 9.2 deals with inverse functions. Now, before we get into finding the actual inverses of functions, we're going to learn about the inverse of a relation. And then we're going to learn later that if a function has the inverse, it's what we call one-to-one. And I'll show you how to check for one-to-one, okay? So let's start with the relations. To find the inverse of a relation, we simply switch the X and Y's. Okay. All I'm going to do when I find the inverse is just switch the X and Y's around and be done. So first, they're going to give us a set of ordered pairs, and then they'll actually give us an equation. So y'all watch this when we do the ordered pairs. All right, so they say find the inverse of the relation. Okay, the relationship is a set of ordered pairs. I got -9, 2. My next one is 6, -6. -5, 9. And finally, 5, -5. So they're going to give you this. Now on the answer, they'll give you the curvy parentheses, but you got to put in all the other parentheses. Okay. So remember, these are ordered pairs, X and a Y, X and a Y, X and a Y, X and a Y. Now, if I'm going to find the inverse, it says all I got to do is switch the X and Y's. So to find my inverse, I'm switching them two numbers around, and that's going to give me a 2, -9. Then I'm going to come to the second one and switch them so that I get a -6, 6. Now, y'all, you're going to use a lot of commas here because you got to put a comma in between your numbers and then a comma in between each of the ordered pairs, okay? All right, switching this one, I get a 9, -5. And then, y'all, finally, this one, I get a -5, 5. Okay, so switch the X and Y's around and be done. Now, this one has we're going to find the inverse of an equation. So, find an equation of the inverse relation. Okay, they're giving me x to the third y equals -3. So y'all remember, to find the inverse of a relation, I'm simply going to switch the x and the y. So if I switch this x and y, I'll have a y cubed x equals -3. Okay, now notice when I switched to x and y, I didn't move the exponent. All I did was switch them. So instead of the x being cubed multiplied by the y is being cubed multiplied by the x. Okay? Alrighty, so here's the thing now. We're about to get into the functions. Now, for a function to have an inverse function, it has to be 1-to-1. So when we talk about graphing, 1-to-1 means that the y values can only have one x value. Now, remember, we did horizontal line tests last week, and we were looking to see if it was a function or not. So remember, to be a function, the x's can only have one y value. Now, we're looking at what we call one-to-one, and that means that the y values can only have one x. So the x's can only have one y, the y's can only have one x. Now, to check for one-to-one, we use a horizontal line test. So remember, horizontal lines go left to right. Now, if a function is one-to-one, then a horizontal line cannot intersect the graph more than once. Okay, just like the vertical line did the functions, couldn't intersect it more than once. Horizontal line checks for one-to-one, and it cannot intersect it more than once, okay? So these next 4 examples, we're going to be looking at a graph, and we're going to determine if it's one-to-one or not, okay? So this part's not bad. We're just looking at horizontal lines. So for the next 4 examples, using the horizontal line test, determine whether the function is one-to-one. All righty. So this will be like my number 3, I guess. This one, they're showing me part. This is like the x-axis here and the y. They're not going real far down on the y-axis. But y'all, this graph starts from the left and this sort of slowly goes uphill, left to right, and sort of starts curving up. So the question is that one-to-one? Well, y'all, run your horizontal line test. Intersects it once here. Intersects it once here. Anywhere I go on my graph, it's just intersecting it one time everywhere. So, since the horizontal lines do not intersect that graph more than once, this is, yes, one-to-one. Now, y'all, how about something like this? Now, we know that parabola is a function because we've been graphing them all last week and stuff. But the question is this function one-to-one? And that's on y'all.
No.
No.
No, good job, because y'all, if you run horizontal lines, it's going to intersect it on both sides. So good job. That is definitely a no. Well, now this one will be a little tricky to draw here. Let me see. Got my X and my Y. So the middle of it sort of does like an upside down U, but then it has this part coming down. And then on this side, it sort of comes down. Is this graph 1-to-1?
No.
No.
No, because y'all them vertical lines, horizontal line intersects it twice here. And then on this bottom parabola looking part, it sort of intersects it twice. So that is definitely a no. All righty, so I had one more of those. And then we'll get to the gist of what this day is all about. So this will be like number 6 here. And in this graph, we sort of drew graphs like this last week. This graph comes up, sort of curves through the center, and then goes up. Sort of like them, when y'all was doing them X cubes last week, and we had the squiggly line we picked out of. Is it 1-to-1?
Yes.
Yes, good job. Because y'all, no matter where you do your horizontal lines, it's only going to intersect it one time, okay? All righty, so let's get to what today's about. And the big thing about today is finding the inverse of a function. Now, inverse notation is like f of x, but we use a f-1 of x. This is what we call inverse function notation, okay? So, here's the steps to finding the inverse of a function. First thing we're going to do, because we're going to have something like f of x equals 3x plus 2, but it's going to start with the f of x there. So the first thing we got to do is we got to replace the f of x with a y. So now instead of it saying f of x equals something, it's going to say y equals blah, blah, x. So now that I got a y here, I'm going to take the x and the y and switch them, just like we did earlier. So I'm going to switch the x and y variables. So switch them up. At that point, I'm then going to solve it for the y. Once I've got it solved for the y, I'm going to replace the y with the f inverse notation. And I'm going to be done, okay? All righty, Michelle, I got you. Michelle. All right, y'all. So now, here's the thing. To have an inverse, a function must be 1-to-1. Okay, so let me see my chat here. Alrighty. Alrighty, so now I can tell y'all this. 7, 8, 9, 10, 11, and 12. These last six, they all are going to be 1-to-1, okay? So you're going to have to find the inverse for all six of these that are left. All right, y'all, so here we go. Let's start with, this is number 7. Now, these exercises are going to say, for the following functions, A, determine if it is 1-to-1. And then B, if 1-to-1, find its inverse. Now, y'all, let me tell you, these 6 problems are all 1-to-1. So when you get to A and it asks you if it's 1-to-1, put yes, and then find that inverse. All 6 of these are 1-to-1. Okay. Now, the other thing you can do is you can graph it on the calculator and you can see that they're actually 1-to-1 if you want. So number 7 has f of x equals x minus 6. Well, x minus 6 is a straight line, so we know it's 1-to-1 because it's just a straight line going uphill left to right. So we know already that all these are going to be 1-to-1. So the first thing it says, replace the f of x with a y. So turn this f of x into a y. Oh, y'all, so I switched, I got the f of x is now to y sitting here. Next I say, switch the x and y variables. So that means this will be x equals y minus 6. So switch the x and y variables. Well, y'all, the next it said solve for that y. So now we're going to solve this for y. Only one step to get this y by itself. So that for the y, I'm going to add 6 to both sides. So I get an x plus 6 equals y. All right, I solved it for the y. Then it says what? Replace y with the f inverse notation. And I'm just going to put the y on the left side. So I'm going to put my f inverse of x equals x plus 6. So you'll see that the inverses have pretty much the opposite operations of the actual function. So the function is x minus 6. The inverse function is x plus 6. Now, what you're going to put in MATLAB, it gives you the inverse notation. All you got to put in is the x plus 6. And y'all are not too bad. You're just switching stuff and solving them, okay? All right, y'all, question on that? All right, so let's start with number 8. And remember, this is doing the same thing. So number 8, they give us f of x equals 7x minus 9. Well, y'all, that's just another straight line. 7x minus 9, like we graphed the very first week. It would just be a line going uphill left and right. So it is 1-to-1. So that means we're going to replace the f of x with a y. So I'm going to get y equals 7x minus 9. Y'all, what's my next step?
Reverse.
Mm-hmm.
The
So
X
we'll
and the
put
Y.
her,
Yes.
and then that'll be what, a 7y minus 9. All right, y'all. So we're switched. Now we're going to solve that for the y. So let's add 9 to both sides. So remember, right here we're just solving for y. So I'm going to add 9 to both sides. So that's just the x plus 9. That's going to equal to 7y. All right, still solving for that y. I need to make that a 1y. So we're going to divide both sides by that 7. So those 7's cancel. That gives us our y. Y'all, we can't do nothing with that. So that's just going to stay at x plus 9 over 7. So now we solved it for the y, and then finally replace the y with the inverse notation. And what you're putting in MATLAB is going to be the x plus 9 divided by 7. See, it's still opposite operations. Up here, the 9 was being subtracted. In the answer, it was being added. Up here, the 7 was being multiplied by the x. Down here, it's being divided. Right now, this next one, I ain't gonna lie, this next one's a little tricky. F of x equals 8 over x plus 1. And yes, this is 1-to-1. So they're all 1-to-1, like I said. So replace the f of x with the y. All right, the y is now, the f of x is now y. Now we're going to switch them, remember? So this will give me x equals 8 divided by y plus 1. And y'all, I'll tell you the truth. This problem here is mainly why we had to do the first 2 in support. Because I can make this x look like a fraction by putting a 1 under it. And remember, to solve this, I would treat this like I was cross multiplying this, okay? But I'm going to show you a trick on this one. So this x gets multiplied by the bottom of that side, which is y plus 1. And then this 1 gets multiplied by the top, which is 8, which gives me 1 times 8 is 8. Now, y'all, here's the thing. I'm not going to distribute this x into these parentheses, because all that would do is give me an x times y and an x times 1. That makes that 1x into a bunch of x's. So what I'm going to do, since this x is being multiplied, can I not come in and divide both sides by that x? Because see, by dividing by x, it now cancels out the x. And then on the right side, I divide by the x. Look what happened in the long run. In the long run, all that happened, we switched these. We put the y plus 1 up here and the x on the bottom there. All we did was switch them around. So y plus 1 equals 8 over x. And y'all, we got one more move to solve to get the y by itself. And that's to come in and subtract 1 from both sides. So that cancels, leaving the y. And y'all, that's an 8 over x minus 1. We can't do nothing with that, so we're going to leave that at 8 over x minus 1. We now solve for the y. So now replace our y with our f inverse notation. And in MATLAB, we're going to put 8 over x minus 1, okay? So I didn't box this one, so all we're actually doing is putting in the actual answers. So y'all be careful. This is probably the trickiest one on there. And it's because of some of these steps. Now, you could have worked this out in the long run and distributed x, but it would have been a lot longer problem trying to get that x back to being 1x, okay? All right, let's see what we got next. All right, y'all, let me get another piece of paper here. All right, so this should be number 10. All right, now, for 10, they give me f of x equals x to the third minus 4. So this would be sort of like the squiggly cube graphs, 1 to 1. So replace the f of x with a y. All right, y'all, switch the x and y around. Now remember, only move the variable, not the exponent. So this will be x equals y to the third minus 4. So now, you remember a while ago when I had cube roots? I tried to get the cube root by itself so that the exponent could cancel the cube root. Well, when you got variables to exponents, you try to get the variable by itself with the exponents, and then to undo a cube, we do cube roots to both sides. So exponents undo cubes, cubes undo exponents, okay? So just recall, if I had any number to an exponent, if I take that root of it, if I take the root of a variable to an exponent and the exponent matches the index of that radical, these cancel, leaving the a. So I can raise radicals to exponents to get rid of the radicals. I can take roots of exponents to get rid of those roots, okay? So we're going to get to y3 by itself by adding 4 here. So y'all, I get an x plus 4 over here equals y to the third. Now I want to turn this y to the third right here into just a y. So here's my y to the third, which means I'm going to take a cube root of this. So right here, I'm going to cube root both sides. So the cube root x plus 4 equals the cube root of y to the third. Well, let's look here. We can't do nothing to this side. That's going to stay a cube root of x plus 4. Well, y'all look here. This cube root cancels with that exponent, leaving me a y. Now remember my last step, replace the y with f inverse of x, and then that'll equal a cube root x plus 4. Okay, so y'all, that's the trick on this, okay? Remembering that radicals undo exponents, exponents undo radicals. Did y'all have any questions on this one?
No, sir.
All righty. Now check this one out. Y'all, this one has f of x equals 2x squared plus 3. And then right behind it, it says x greater than or equal to 0. Now, I'm going to tell you this. If we was to graph this, it would look like this. We all remember x squared graphs give us parabolas. Well, this is not 1-to-1, but look what they're saying right here. Right here, they're saying, hey, x can only be greater than or equal to 0. Well, y'all, here's 0 right here. So they're only looking at this graph for any x values that are to the right of the 0. So they're not looking at this side. So this ain't here. All they're doing is looking at it from 0 on. And if you restrict the x's from 0 to infinity, that means that this part of the graph is 1-to-1. So they can make a parabola 1-to-1 if they restrict the domain, okay? So that means this thing does have an inverse. So we're going to replace f of x with a y. Remember, this ain't part of the function. It's just telling me that they only want me to look at the graph from 0 to the right, okay? All right, y'all. So I replace f of x with the y. What do we got to do next? And y'all, I'm going to show you something on this one. On this one, they give you this much of the answer. It's got a box on top over a 2. So we know when we're done, it better look something like this, okay? And we got to figure out what goes to the top of this fraction. So like I said, they gave us that much of the answer. So to get to this, what's your next step?
Switch Y and X.
All righty. So x equals 2y squared plus 3. Now, y'all, start solving for the y. Now, remember, we got to get this y squared term by itself first. So we're going to move this 3 by subtracting. So this is x minus 3 equals 2y squared. Now, there's another move I'm going to do before I take care of that exponent. And that is to move this 2 off of that y there. So since this 2 is being multiplied by the y squared, I'm going to divide both sides by 2. Because remember, we want that to be a 1y squared. So this 2 divided by 2 will make that a y squared. Over here is going to be x minus 3 over 2. All right, y'all, the last move. Turn that y squared into a y. Well, up here, radicals undid exponents. Here's an exponent. So I'm going to undo that by using a square root. So the square root of x minus 3 over 2 equals the square root of y squared. And y'all, guess what? I can't do nothing with this side. So it's going to stay a square root of x minus 3 over 2. But the square root of y squared is y. So the question is, what are you putting in that box? And that would be?
X minus 2.
X minus 2.
Uh-huh.
I mean, X minus.
Uh-huh. Because the
3.
2's already here. Well, we got a 2 on ours. The square root was already there, and we got a square root on ours, okay? So, although if you graph it, you see a parabola, remember, they're restricting our domain here and only looking at the x's that are greater than 0. So that's how we sort of work around those, okay? All right, y'all. So one more for college algebra, and then that'll be a wrap. So this one has f of x equals a square root x plus 4. All right, so if you used to graph that, and it would be a graph sort of slowly going uphill, but it is 1-to-1. So you're going to replace the f of x with a y. And I'm just following them steps I gave y'all a while ago. I'll replace f of x with a y. I'm going to switch to x and y. Now, here's something. We need to solve that for the y. But y'all, I cannot subtract 4 yet because this y plus 4 are both under that radical. So what I need to figure out, y'all, how can we get rid of that radical?
You have to square it.
I got to square it. Good job. So the x squared will equal the square root of y plus 4 squared. So look here. Can't do nothing here. That's going to stay at x squared. But y'all here, that radical cancels with that exponent, leaving you a y plus 4. So remember, when you're doing inverses, if they got radicals, you're going to end up with squares. If you start with squares, you're going to get radicals, okay? Oh, we got one more move here, don't we? I got to get to y by itself. So we're going to subtract that 4 from both sides. And I get my x squared minus 4 equal to the y. So here we go. F inverse of x equals x squared minus 4. So square roots, squares, adding 4, subtracting 4. I want y'all to notice those opposite signs going on these, okay? All righty, y'all. So that is the college algebra 9.2. So I'm going to stop that share. So y'all, what questions y'all have over this? I'm going to check and make sure I got everybody real quick. Looks like I do. All right, looks like I got everybody. Latarsha, you had a question?
No. No, I
Oh,
do.
okay.
That is not the same.
All right, so I'm going to quit that.